Hello everyone and welcome to our online version of ECE 106, Electricity and Magnetism. It's my pleasure to try to provide you the resources required to learn the course. We're going to run it quite differently than we normally run, but I think we have an exciting course ahead for you, and hopefully we would all learn over the next 3 months or so. My name is Simarjit Seni, and I'm an associate prof in the Department of Electrical and Computer Engineering. And I'll probably get to see you, hopefully, when you come back on the campus again. The course is going to be related with 4 equations. These equations were originally created by James Maxwell around 1860s, mid-1860s, 1866. And in their final form were created by Ampere and Heaviside in mid-1890s. These equations form the very foundations of our department, of our field. And not only that, these equations are the foundation for most of 20th century physics and engineering. Most of the technological advances we made in the 20th century can be traced back to these equations. So they're quite exciting to learn in that way. What we have done is combine the 2 sections together. So we will provide you combined resources between me and Professor Brenda Lee from the physics department. Hopefully we will have a good, fruitful term. The course material would be put on Learn on a weekly basis, and the material would include written notes, and based on those notes there would be videos explaining those notes, and we will have problem sets for you to consolidate the material you are learning. This material builds upon itself, and this is a new way of doing physics which you probably have not seen before. So it is very important in this course that you keep up on it on a weekly basis. Whatever we cover in a specific week, you should be doing that in that week itself. Otherwise, it becomes almost impossible to dig yourself out of this course material. So you need time for you to really understand electromagnetic theory and thus give yourselves those time. Both Professor Lee and I will give you lots of resources, including live sessions, besides the online stuff we are putting on, and office hours too. So I'll have office hours on Sunday before your quiz if you have any questions, and we'll have office hours spread out during the whole week. We'll also have some live sessions where we will take some of the more difficult problems and try to help you solve those problems based on the material we have taught. Hidden within the material, hidden within the notes, when you read the notes, you will see that there are some bonus grades given. So you have to read those notes to figure out where those bonus grades are. And you can earn up to 3% extra grade by reading through the notes and finding out and answering the questions which are asked as bonus in the notes. So I hope we have a good, exciting term in whatever circumstances we have now. But not only an exciting term, but a term where we learn something. You learn from me and I learn from you of how to teach effectively. And we get to meet in much happier times.
Hi everyone, welcome to ECE 106, Electricity and Magnetism. My name is Brenda and I'll be one of your professors this term for the course, alongside Professor Simarjit Seni from Engineering. I myself am a full-time lecturer in physics and astronomy, so between the two of us, hopefully you'll get to see different perspectives in terms of applications for E&M. So there are two sections to this course, Section 1 and Section 2, but Professor Saini and myself have decided to pool together our resources due to these times and give you the best learning experience possible. So we've tried our best to give you as many resources to learn from. There are course notes from Professor Saini that he's developed over the years. These are really good. We have pre-recorded lectures based off of these notes, as well as live lecture sessions that are offered each week. I would definitely recommend those because apart from just going through the pre-recorded lectures, which give you the basics and have some simple practice problems, the live lectures are going to go through many more complex problems, as well as a good recap of what you've learned in the pre-recorded lectures. So ECE 106 is a course that's all about electricity and magnetism, as you probably imagined. But at the core of this course are 4 equations called Maxwell's equations. So these famous equations form the foundation of the entire field. So throughout the whole course, we're going to dedicate ourselves to learning these equations, and not just learning them, understanding what they mean and being able to apply them to different scenarios and problems. In terms of the course structure, there's 5 different components. There are weekly quizzes worth 20%. There are 2 assessments. So there's the midterm assessment, which is worth 25%, and the final assessment worth 20%. After that, there are labs that are worth 15% and a final design project worth 20%. That design project is a cumulative project that pulls together concepts from different courses you've taken in your undergraduate career so far. So hopefully that will be a fun project for you to take on in the latter half of the term. So apart from all this, this all adds up to 100%. There's also a bonus of 3%. And that bonus of 3% is found in these course notes. So it's an incentive to read the course notes and stay up to date on your content. One thing about this course is that we build up on concepts very, very quickly. So if you fall behind, it's really hard for yourself to pick yourself back up again and catch up. So my recommendation is to stay on top of the weekly schedule, which is available on Learn. To help out with this and to keep you on track, Professor Saini and myself have also created a weekly checklist. It's available on Learn under Resources. So go to the checklist module. You'll be able to see a weekly checklist, and every week you can just check off everything that you've accomplished. Definitely stay on top, do not fall behind, and most importantly, seek help when you need it. So apart from the course notes, the pre-recorded lectures and the live sessions, Professor Saini and myself were very helpful people, and we offer tons of office hours and support. So throughout the whole term, if you're ever struggling, watch out for our office hours. We'll have multiple office hours throughout the week. Apart from that, we've created a Facebook group that you can join, and we'll be a part of the discussion as well, but we're trying to get the whole class to engage with each other. So join the Facebook group, we'll be there as well. If you have any questions, concerns about the course, or just want to talk to your peers, join the group. We'll be monitoring it and we'll help out if others can't help. There's also a huge support system from the TAs. There are TAs from engineering and also TAs from the physics department. And there are many TAs that are going to offer office hours as well to help you in your studies. On the topic of support, we understand that doing practice problems is really important for any math-intensive course like this one. So after you've looked at the pre-recorded lectures and the live lectures for a week, we're going to be releasing weekly problem sets for you to do practice problems. So try and do those weekly problem sets, and it's up to you to perform some self-reflection to see if you're understanding the question or not. If you're struggling with any of the questions, do use our office hours and ask questions, because we can't learn anything without asking questions. So if all the problem sets are really easy to you and you want a challenge, there are 2 textbooks over here that you can look at for advanced knowledge of electricity and magnetism. There's really good explanations for what we're going to learn in this course in these textbooks, but there are also many concepts that are above the level that you need to be at here. So there's Electricity and Magnetism from Edward Purcell and David Morin. This green book over here is probably one of the most challenging E&M books, but it does a really good job of explaining complex concepts. So do take a look at that if you want a challenge. There's also this blue book over here. It's called Introduction to Electrodynamics by David Griffiths. This book is more applied. It has really good questions and applications to physics and engineering. To end off, I do hope you enjoy this class, and keep in mind, everything is online this term. Stay safe, and most importantly, stay in touch. As instructors, we do love the interaction with students, and unfortunately with everything being online, we're trying to encourage as much engagement as possible. Even though this whole course is going to be a learning experience for you, it's also a learning experience for myself and Professor Saini. We would really love your feedback throughout the term. Don't hesitate to contact us if you have any problems, and most importantly, don't stop asking questions if you have them.